Good morning all. Welcome back to our course on the C programming language. In this session I am going to discuss about a concept on multidimensional arrays. In the previous discussions about these arrays, we have discussed the concept of types of arrays, where we have seen two types of arrays, that is one dimensional array. In simple form we will call it as 1D arrays, and the other type is the multidimensional arrays, where we have more number of dimensions, where we can store huge amount of data. All these things we have discussed, right? So in today's session we are going to go deep into the concept of these multidimensional arrays, where we will be concentrating only on the 2D arrays. So multidimensional means more than one dimension. That means it can have 2 dimensions, or it can have 3 dimensions or 4 dimensions. But as we increase the dimensions of the array, the complexity of the programming as well as the memory representation, everything becomes complex, right? So we will be confining our definitions or the discussion of the multidimensional arrays with these 2D arrays only. So in today's session we will be discussing about what these 2D arrays are. What are these 2D arrays? And after this we will discuss how we can declare the 2D arrays. We will see one example of declaration of these 2D arrays, and then we will see the total number of elements, and the total memory that is occupied, and then we will see what is the memory representation of the 2D arrays. So let us start our discussion with the definition of the array. We know very well that an array is nothing but a collection of elements of similar data type, and they occupy the contiguous memory locations. So the definition of 2D arrays also remains the same, but what happens in 2D arrays means you are going to store more number of elements, you are going to store huge amount of data. That is the only difference. So the definition part of the arrays remains the same. It is a collection of elements of similar data type. This we have seen in the previous discussions also, right? Now coming to the concept of 2D arrays, we can say that these 2D arrays can be visualized, or we can say that it is an array of arrays. It is an array of arrays. And the second point regarding this 2D arrays is they are organized in the form of matrices. We know how these matrices look like, and how these tabular data, what we come across in the database management system. So these matrices and tabular data, they consist of rows and columns, right? So whenever you want to organize the data in the form of rows and columns, then you can think of the concept of 2D arrays in the C programming language. So simply remember that when you need something to be organized in the form of rows and columns, just go for the concept of array of arrays, which is nothing but the 2D arrays. And similarly, as I have been telling you from the first starting point onwards, these 2D arrays are used to hold bulk volume of data. These are the three major important points regarding these 2D arrays. This D is nothing but dimension, 2-dimensional arrays. In short form, we are calling it as the 2D array. So it is array of arrays, and it is organized. The array of arrays will be organized as matrices, which can be represented as a collection of rows and columns. And similarly, these 2D arrays are used to hold bulk or huge amount of data. This is what the 2D arrays are. The first part we have completed, and let us go to the second part of how we are going to declare these 2D arrays. Declaration part. When we want to declare an one-dimensional array, we know that we will be doing it in terms of first we will make use of the data type, and then we will use the array name, and then we will use a square bracket, and within the square bracket we will specify the size. In the similar fashion, we will be declaring these two-dimensional arrays in the same fashion. That is, for declaring a 2D array, you will have to make use of a data type, and as I told that this data type can be a fundamental data type or a user defined data type also, whatever it may be. So this is a data type. After data type, you have to make use of the array name, which is nothing but an identifier. So whatever rules that we apply for the identifiers, they should be applied for this array name also. And after this, you should be somewhat careful here that since you are going to declare 2 dimensions of an array, so there should be 2 square brackets, 2 pairs of square brackets. The first pair specifies the first dimension, that is, we call it as rows, and the second pair or the second box represents the columns. So this is one dimension and this is another dimension. So if you look at this common declaration, you can simply say that this is nothing but an array of arrays. That means you are arranging the arrays, and those arrays has to be declared as another array. This is a common or a generic declaration where we will be using the data type, array name, and 2 dimensions. One to specify the rows. You remember that the first dimension always specifies the number of rows, and the second dimension always specifies the number of columns. So let us take an example here. Then we will discuss what are the number of elements and what is the total size occupied by all these elements. Everything we will discuss. So let me take an example of the data type. Here I am going to take a fundamental data type, which is an integer, and I am going to take the array name as A, capital A, and after this I am making use of 2 pairs of square brackets, and let me take the row size as 2 and the column size as 3. So when we declare an array, a 2D array like this, when the compiler comes across this statement, it will come to know that the user is trying to declare an integer array which consists of 2 rows and 3 columns. So the total number of elements, so here we have 2 rows and 3 columns. That means each and every row is having 3 elements. So for example, these are the 3 elements in my first row, and these are the 3 elements in my second row. So this is having 2 rows and 3 columns. So this is an example, and let me take one more example, not with the integer data type. For example, I want to declare a character array. So I should make use of the data type as char. This is example 2, char, and after char you have to specify the name of the array. Let me take the character array name as ch, and since it is a 2-dimensional array, remember that you are going to declare 2 dimensions. One is the rows and the second one is the number of columns. Let me take the rows as 5 and the columns as 5. So here it is going to declare a character array that consists of 5 elements in each of the row, and there are 5 such rows in it, right? So 1 2 3 4 5 characters like that. I have 5 different rows like this. So this is how we are going to declare a two-dimensional array. And let us discuss what is the total number of elements that are taken in these examples. If you consider the first example where I have declared an integer array that consists of 2 rows and 3 columns, here you can see that there are total 6 elements. Similarly, in this second example where I have declared the character array, you can observe that there are 5 into 5, that is 25 elements. So the common formula for the number of elements in a 2D array is equal to the row size into multiplied by the column size. This is a generalized formula. So if you consider this first example, here the row size is 2, and the column size is 3. So the total number of elements that are present inside this array is 2 into 3, that is 6 integer elements. So the array A is going to hold 6 integer values. And if you consider the second example, here the total number of rows is 5 and the total number of columns is 5. So the total number of elements is equal to 5 into 5, that is 25 character elements. So the array CH is going to store 25 character values. And this part also we have completed. And the total memory that is occupied, this is very important. So the total memory that is occupied by the array is equal to the number of elements multiplied with the size of each individual element. Let us go with the first example. The total number of elements are, we have calculated in the previous discussion that total number of elements is equal to rows size into column size. So 2 multiplied with 3, that is equal to 6. The total memory that is occupied is equal to number of elements multiplied with size of each element. This is the generalized formula. So the number of elements is 6 when it is multiplied with the size of each element. Since the integer occupies 4 bytes, each and every integer occupies 4 bytes, let us take it as 4. Therefore that is equal to 24 bytes in the first example. So in the first example, it is going to take, or it is going to allocate 24 bytes of total memory. And if you go with the second element, I know that it is having a total number of 25 characters. And when I want to calculate the memory occupied, so the total memory occupied is equal to the total number of elements, that is 25 multiplied with size of each element. Here you can see that each and every character in the C programming language occupies only 1 byte of memory. So 25 multiplied with 1, it is equal to 25 bytes. So this is how we calculate the total memory occupied by every two-dimensional arrays. And the last topic of our discussion is the memory representation. When coming to the concept of memory representation of the two-dimensional arrays, it can be done in two ways. It's not the representation can be done in two ways. It can be viewed in two ways. One is the conceptual representation, and the second memory representation is the actual representation. The conceptual representation is how we are going to view the data of a two-dimensional array. We know that the two-dimensional arrays can be utilized for representing the values which we want to view or show in terms of the rows and columns. So the conceptual representation will be, so let us take a common example what we have taken in the previous example, right? So it is int a of 2, 3. I'm taking an example of integer array that has 6 elements, that is 2 rows and 3 columns. While coming to the concept of conceptual representation, memory representation, you assume that everything in terms of a table like this. In this particular table you have 2 rows, okay, therefore I take 2 rows. This is row 1, which I can take it as, we know that the index always starts with 0 and ends with n minus 1. So the row index at this example is going to be 0, 1. In the similar fashion, the column index in this example is to be 0, 1 and 2. So this is the 0th index or 0th row, and this is the first row. In similar manner, if we want to represent the number of columns, I know that here the number of columns is equal to 3. Therefore, you divide this table into 3 parts like this. And this is the 0th column in this fashion, this way. This is the first column and this is the second column. So the horizontal things represent the rows and the vertical things represent the columns. This is how we are going to conceptually view or represent the memory for our understanding purpose. And when we go to the inner elements, so this inner element, this first element can be accessed as 0, 0. The second element can be accessed as 0, 1. So you always start with row number and you have to end with the column number. So this element is 0th row, second column. So it is 0, 2. If you consider this particular block, it is first row, 0th column. This one is first row, first column. This is first row, second column. So this is how we are going to view the things in the memory conceptually. But the actual representation, how the memory is going to be stored or allocated by the compiler, is something similar to like this. It is viewed as a single block, not as this table. But we have 6 elements, therefore you will be dividing this into 6 blocks like this. The first element is 0, 0. The second element will be 0, 1. This is 0, 2, and here it is 1, 0, 1, 1 and 1, 2. So this is the actual representation how the compiler is going to allocate the memory for the 2D arrays. This is for our understanding purpose and this is for compiler. Let us take the address parts also. Right. If you take the base address of the array A as 100 and every element occupies 3 bytes of memory, the second element, that is 0, 1 element, will be at the 103 base address. So 100, 101, 102, 103, this will be occupied by the first cell, and here it will be 104, sorry. And the third element will be occupying the 108 base address, and after 4 locations, 10 element, this element is having the base address as 112, and 11 element will be having the starting address as 116, and the last element will start at 120. The same thing happens in this actual representation also. So this is 100, this is 104 starting address, this is 108, starting address of 10 will be 112, starting address of 11 will be 116, and starting address of 12 element will be 120. This is the representation, memory representation that happens in the 2D arrays. So this is what I want to discuss in today's session. Let us have a quick recap of what we have discussed in today's session, right? So we started our discussion with the definition of an array, and then we have seen some of the important terms that are related to the 2D array. That is, the 2D array can be viewed as the array of arrays, it can be viewed as matrices, and you will be using this 2D array whenever you want to represent the data in the form of rows and columns, and it is used to hold bulk of data. And then we have gone through the declaration part. We have seen the generalized declaration of how we can declare the 2D arrays, that is the data type followed by array name, and the 2 dimensions should be specified with the two pair of square brackets, right? We have seen 2 examples of declaring an integer array and character array, and then we have moved our discussion towards the total number of elements. The total number of elements that is occupied by a 2D array is equal to the row size multiplied with column size. And then we have discussed what is the total memory that is occupied by these 2D arrays, which is equal to the generalized formula of total memory occupied is equal to the number of elements multiplied with the size of each element. And we have seen what is the total size occupied by these 2 examples, that is the integer array and the character array. And finally we have discussed the concept of the memory representation of a 2D array. As we have discussed, the memory representation can be done as a conceptual representation and the actual representation. In the conceptual representation, you will be viewing the data in the form of rows and columns, and in the actual representation, you will view everything in the form of a single row, and you will have different blocks or elements that are stored in the contiguous memory locations. So we have seen the index of each and every element. The index of each and every element should be represented as the as a block of 2 numbers. The first number indicates the row number, the second number indicates the column number. So that's all for today's session. Thank you one and all for joining the session.